So here are the steps for finding a percentile for a sample mean. The first step is to see if the central limit theorem holds true. If yes, then we can continue. If not, then we're kind of a little stuck here. But I usually won't give you a problem where the central limit theorem doesn't hold true. And the next phase will kind of loosen our rules for the central limit theorem. Like, we won't have to have the random sample. And we'll still calculate probabilities, but for now, we're going to be pretty strict about it. So first you want to see the central limit holds true. If so, we're going to continue. If not, we just kind of stop and say we can't really finish the problem. Step 2 is to describe the sampling distribution. So you want to know that the sampling distribution is normally distributed, that it has a mean of the population mean, and a standard error of the standard deviation divided by the square root of n, or the first version of it, which is the square root of the variance divided by n. And third, we're going to find a z-score with this formula. And fourth, we're going to look up the z-score up in the table, because the table gives you the percentiles. So now I'm going to go over a percentile example. Here we have a skewed distribution with test scores across Asia. And these test scores have a mean of 100 and a standard deviation of 12. And the question is, what is the percentile for a sample mean of 96 based on a random sample of 36 Asians? So for this question, it's asking about a random sample and what is some sort of probability for that random sample, for that sample mean. So in that case, we need to know if the central limit theorem holds true. So the first step is, does the central limit theorem hold true? And yes, the n is at least 30. It's 36. And we have a random sample. So this second step then is to describe the sampling distribution. And we kind of did this already in the other video. But here we have the normal distribution. We know it's normally distributed because we have a n of at least 30 and it's a random sample. Our mean of our sample means is equal to the population mean, and we know that is 100 because if we look up here, we know that the skewed distribution, which is the population distribution, has a mean of 100. So we can go over here and say on our sampling distribution, the middle is 100. And then we need to find the standard error, which is the standard deviation of the sample means here. And in this one, we're going to use this formula, which is the standard deviation divided by the square root of n, because we already have the standard deviation instead of the variance. So we know that the population standard deviation, right, the skewed distribution up here is the population distribution, and that distribution has a standard deviation of 12. So that's going to go on the top of our formula, and then we're going to divide by the square root of our 36, which is our n. So we end up having 12 divided by 6, which equals 2. So then we can go over here and go up one standard deviation to the right and get 102, and then we go another standard deviation to the right and get 104, and then go another standard deviation to the right and get 106. And then we can do the same thing here, but go to the left, and so we get 98, 96, and 94. Okay. Then our next step is to find our z-score. So the sample mean that we were talking about was 96, so that goes first. This is the sample mean, not the population mean of the sample means. Then we subtract the population mean, or the mean of the sample means, which is the population mean. And then we divide by the standard error of 2. and that ends up being -4. 96 minus 100 and divide by 2, we get -2. So you can also put this in z-scores here. So 100, which is the mean, would be 0. 102 would be 1. 104 would be 2. 106 would be 3. And then we go to the left, it would be -1, -2, and -3. Now I'm going to draw a line here at our z-squared of -2, or our sample mean of 96. So here's our line, and we're trying to find the percentile. So I want the area to the left here, because the percentile is the area below a value. So this is what we're looking for in the z-table. So we're going to go to the z-table, and you should find 0.0228. And if you don't know how to find this, I'll show you how to do it on the next slide. But remember, the z-table always gives you area to the left, and that's what we're looking for, so we don't have to go to the 5th step. So now I'm going to talk about how to use the z-table. So we were looking for a z-score of -2. So we're going to go to this first column here first. But you should know that the z-table only gives area to the left here. It's called the standard normal probabilities because it's for z-scores. And z-scores have a mean of 0 and a standard deviation of 1. So that's what it means for standard normal. So it's for a normal distribution with a mean of 0 and a standard deviation of 1. So that's what it means by the standard normal probability. So it's basically, you can look up z-scores if we have a normal distribution already. And it gives you area to the left all the time. So if you don't have a percentile, if the percentile is not the question, then you have to do a little bit more math to find it. But we're looking for -2 here, so we're going to go to this first column here, and we're going to find -2. Great. And then you always want to round your z-scores to the second decimal place. So because there's nothing really there, we're going to go 0.00. And so that means we're going to go to this second column here. So you should note that this first 0 here that I'm underlining corresponds with this 0 in the first column. So the first column, or labeled Z, gives you the first number, which is the whole number before the decimal, and then it gives you the first decimal. So it's going to be -0 there, and then the other columns here give you the second decimal, so 0. So we kind of just ignore all of these zeros here. They really don't mean much. And that's for all of them. So then we look at the intersection of these two, this row and this column, and we get 0.0228, and that's the percentile for a z-score of -2.